suppose we'd like to graph this line. There are lots of ways to graph a line, but an easy way to do it is to simply take the x-intercept and the y-intercept and plot those 2 points. Well, how do you do that? To find the x-intercept, we set y equal to 0 and solve for x in this equation. To find the x-intercept, we set y equal to 0 and solve for x in this equation. So here, some people like to make an xy table, and then if I put in 0 for x, I can plug it in here and find y. Next, we'll put in 0 for y, put it in here and find x. So let's see what that looks like. If we put in 0 for x, we get 0 plus 3y equals 6. If we divide both sides by 3, we get y equals 2. So when x is 0, y is 2. That leads us to believe that this would be the point on the graph, 0, 2. All right, now let's do the second one. To find the other intercept, we set y equal to 0 and solve for x. So that would be x plus 3 times 0 equals 6. 3 times 0 is 0. So I get x plus 0 equals 6, or x equals 6. Thus, 6 for x and y for 0 are a pair that make this equation true. Thus, the point would be 6, 0. Now let's recall how to plot a point. This is the rectangular coordinate system. This is the x-axis and this is the y-axis. So if I wanted to plot, for example, 1, -3, this won't be on the line, but let's just practice with it. We'd start here at 0, 0. We move 1 to the right and 3 down, and this would be our point. This would be 1, -3. No, we always start at 0, 0. We don't move over 1 and draw a dot, and then move down 3 and draw a dot. We move over 1, don't draw a dot, then move down 3, and that's when our dot happens. All right, so let's plot these 2 points, 0, 2, and 6, 0. Starting from 0, 0, we go 0 to the left and right, and then we go 2 up. Again, starting from 0, 0, to plot 6, 0, we go 6 to the right, and then 0 up or down. Now we have to connect the dots with a long straight line. Are there only 2 points on this line? No, there are infinitely many points on this line. For example, the point 3, 1 would be on this line. 0, 2, 6, 0. And we could keep going in the direction to the right and to the left. There are infinitely many points in any direction. In fact, there are even points in the middle here, but they have not as nice a number, so we want to know that there are points represented, but we don't necessarily need to be able to calculate all of them all the time. It's a lot nicer to graph a line using easy numbers, even if I could put 1.5 in it for x and get a value for y. That doesn't mean we necessarily want to, but we want to know that it's possible that this connected line between these 2 points implies that all of these points in the middle do lie on this line. Let's look at a second example. Graph 2x minus 5y equals 10. We graph 2x minus 5y equals 10. Again, I'm going to use the intercept method. So I'm going to draw a table like this with x and y. I'm going to put in 0 for x and see what I get for y. I'm going to put in 0 for y and see what I get for x, and those will be 2 points on the line. So, x, y. If x is 0, then we get 2 times 0 minus 5y equals 10, or minus 5y equals 10. Divide both sides by -5, and y equals -2. Recall that 2 times 0 is 0, and 0 minus 5y is minus 5y, so that's why that just kind of vanished out of there. So if y is minus 2, then we have 0 minus 2. So our point will be 0 minus 2. All right, let's calculate for the other point. We already found y when x is 0, so now let's find x when y is 0. So that would be 2x minus 5 times 0 equals 10. So minus 5 times times 0 is minus 0. 2x minus 0 is 2x. If 2x equals 10, and we divide both sides by 2, then we get that x equals to 5. So 5, 0 would be another point on the graph. Starting at 0, 0, I move 5 to the right, then I move 0 up and down. So here is my point on the graph. Again, I need to connect these with a long straight line, because a line does not just end at the intercepts. Some students will do this and say, oh, there's my line. No, a line continues infinitely far in both directions, keeping the same relationship. All right, I want to ask any questions, but obviously if you have them, you'll have to send me an email. All right, so now let's talk about the slope of the line. This type of problem is covered in sections 11.1 and 11.2, but slope of a line is covered in 11.3. The slope of a line is a measure of its steepness. So for example, if we're going to build a ramp that someone is supposed to roll a wheelchair up, it can't be like this. It's not like a ski slope where it's more exciting if it's higher. It's got to be moderately steep, so it gets from the ground up the stairs, but it can't be so steep that it's dangerous. Thus, we have a numerical measure of the slope of this ramp. So when we look at a slope of a line, the measure of that is called slope, or rise over run. Slope of a line is rise over run. So what does that mean? Well, if we look from this point to this point, here the rise is 1, 2, 2. And here the run is 1, 2, 3, 4, 5, 6 is 6. Now, are either of these negative? Since we go down to do the 2, that is negative. Since we go right to do the 6, it is positive. Had we gone left to do the 6, that would be negative also. Had we gone up to do the 2, that would be positive. So here, the slope, which is referred to as m, because the Greek word for slope begins with m. I'm just joshing you. We don't know why we use m, we just do. So this is the rise, which here is minus 2, over the run, which is 6. And now we can reduce that to give us minus 1/3, and we should always reduce our slopes. So the way I like to do it is pick a point, and then go up or down so that we can get to the next point. So here I go down 2, and then right 6. So down 2 is negative 2, and then right 6 is plus 6. Let's suppose I started from this one. Then I go up 2, that'd be plus 2, and then that would be over left 6, but left 6 would be minus 6, so that'd still be 2 over minus 6, or minus 2/6, or minus 1/3. So any way you do it, the slope comes out the same. So try, just for an exercise, to calculate the slope of the other line. This is your thinking music. And try using the slope, the rise over the run, with the line that is given. All right. Hopefully that was enough time. So let's start at this point, because it's the closest one to me. Doesn't matter which one I pick. I go up 2, so that is a rise of plus 2. I know that slope is rise over run. So this would be plus 2 over. Now I'm going to go right. 1, 2, 3, 4. Oh, it looks like that's 5. So I'm going to go right 5. So the slope here is rise over run, or 2/5. So here the slope is positive. I hope you got that one right. If you did, good job. If not, do you see how you approach it now? And if you start from either point, you will still get the same slope. All right. So now I would like us to talk about how to find the slope when you're given the point on the line. So suppose you would like to find the slope of a line passing through (3, 1) and 6, 0. All right, so we have an equation or a formula for that. The rise is really the change in the y value, right? The y changed from being 0 in this point to being 2 in this point. So the change in y over the change in x. Right? This is really the run is really the change in x. The x here changed from 0 to 6. So in an equation form, the slope is equal to y2 minus y1 over x2 minus x1. Now don't let these little small numbers scare you. All this means is, look, if this is our first point, then this x1 and y1 have to both come from this point. If this is our second point, then this x2 and y2 have to both come from the second point. There's no mixing and matching. It's all got to come from one point. So let's make this one our point 1 and this one our point 2. Then y2 minus y1 is y2 minus y1 over x2 minus x1. This is x2 minus x1. Now, does it matter which one you pick for point 1 and point 2? It doesn't. You'll get the same answer either way. So just pick the closest one to you or your favorite one or whatever. So here we get -1, and here we get 3. Look, the slope is -1/3. That's exactly what we got here. So we can find the slope of the line if we simply know 2 points on the line. Now, there's another thing we can do, is that we can graph a line if we only know the slope of the line and the y-intercept. So let's erase this part and let's do a problem like that. All right, let's graph a line with slope minus 1/3 and passing through All right, so we're going to draw our axis. This is the x-axis, and this is the y-axis. And we're going to need a few points here. When you use my MATLAB, the grid will be drawn for you, but it is nice to be able to use an actual grid. There is free graph paper available on the internet if you search for free graph paper online, and you can print it and then you can draw it on your own, so you don't have to do this. I don't know how to get free graph paper for the board, so we're stuck with it. All right, so this is how we do that. First we plot the point. 3, 1. Here's my point. Now, since the slope is -1/3, and remember that slope is rise over run, I have to select where I'm going to make the negative. Is it going to be the top number or the bottom number? I suggest you always make the top number negative because it will be simple. Remember that you're not going to make both numbers negative. It's not -1 for the rise and then -3 for the run also. That's not true. So from here, I want to rise -1, so now I've raised it -1, and then run 3, 1, 2, 3. This is the point 6, 0. Notice that if I connect the dots carefully, I get this line. Notice that this line is the same as that line, isn't it? Yes, it is. I did that deliberately. So sometimes you are given the equation of the line, sometimes you are given the slope and a point on the line, and sometimes that point is the y-intercept, other times it's another point. And either way, we should be able to draw the graph of the line. I hope this helps to make Chapter 11 a little bit easier. Apparently, Test 2 is one of the trickiest tests that we have in this class, so it is really important. And feel free to watch the video over again if you might need to see it more than once.